Hello, my name's Joseph, and I work at Brock Solutions. As part of my role at Brock, I get to help our customers to digitally transform their business by providing real-time solutions to their operations. And our customers are looking ahead to take advantage of technologies that would help them connect their various processes and gain further insights into their operations. One sector that looks to benefit from this is the water treatment industry. Unlike most other sectors, the water treatment industry manages an array of different operations, which is made more complex by the infrastructure that's required to support it. The primary challenge they face is that the information required to operate their facilities effectively lies in the numerous systems they interact with every day. In most cases, these systems lack the ability to share this information, effectively creating data silos. Ultimately, this leads to inefficiencies in their operation. A few years ago, we undertook strategic initiatives and partnered with our customers to break down these data silos and aggregate the information they contain into a centralized location we refer to as SmartWater. The goal was to provide a platform that would suit the current and future needs of the operators. With feedback from process engineers, technical operators, and facility supervisors, we identified three key areas of growth, namely IIoT enablement, predictive maintenance, and operational troubleshooting. IIoT enablement is a general term for connecting various hardware and software platforms together. Our screen here is a good example of this. Here we see a map that is pulling our various assets from our GIS. We can also overlay other information from our system here. Things like the Scada endpoints, allowing us to see which ones are connected, as well as their current status. And we can pull information from public sources, like weather radar and forecasts. This may help with coordinating maintenance operations or planning for heavy precipitation scenarios. We can also click around the map to view important information about our assets and gain further insights. Clicking on the pump station reveals the maintenance activities that have been performed, as well as the KPI parameters like water quality and system health. This presents a robust operational picture and enables the ability to make smarter decisions to better utilize resources, ultimately doing more with less. Let's launch the Scada to take a look at our next example. Here we see a Scada view of the pump station. We can see a few instruments, a couple of pumps, and a water tank. We can click around the different components to get further information on a specific device. Clicking on the pump brings up an info window with the manufacturer and performance information. Having connected this to an asset management system, a technician on site could even pull up product drawings locally to troubleshoot maintenance problems. Having all of this data aggregated allows us to do more interesting things, like predictive maintenance. One quick application is vibration sensors on pump systems. Oftentimes our customers have pump stations in locations where no one is typically present. Scheduled maintenance and periodic inspections are the norm, but leave room for improvement. Simply adding a vibration sensor to an existing pump asset can detect problematic signals as efficiency in the pump begins to drop. This triggers alarms, and control logic can cycle the pump from active duty to standby and wait for maintenance crews to arrive. Here we see that, based on the vibration alarm, a work order has automatically been created to a nearby maintenance crew's schedule. Combining information in this way helps to improve decision-making and reduce overhead of administration, helping to make optimal use of limited resources. In this last example, it's meant to illustrate an operational troubleshooting exercise. In this case, our setting is a wastewater treatment plant. Clicking on the treatment plant brings up its info card, which shows us important information like flow rates, water quality parameters, as well as the status of each treatment step. Notice that the secondary is currently having an issue. Clicking into the problem area brings us right to this location. This brings us to the clarifier screen. Notice that the problem is on clarifier 4. Clicking the clarifier allows us to see all of the process data that's being captured. Because all of these systems are intertwined together and all of their data is exposed, this allows us to do something more interesting to try and understand ways to correct the issue. Clicking the Simulate button allows us to do this. This pop-up is used to build models and integrate with different analytics packages. We select our target location, our target parameter, as well as the desired outcome. We can also select the input parameters we wish to change to see how they affect the outcome. Then we'll click Model. This brings us to the Simulate screen. On the left is the parameters from the previous screen, and on the right is our expected outcome. Through adjusting these parameters, we can see how input parameters affect the output. Once we're satisfied with the results, rather than adjusting specific pieces of equipment required to execute this work, we simply hit the Load button to have all of these changes take effect. Simulation-based troubleshooting reduces the trial and error taken to resolve operational problems. Ultimately, this minimizes tribal knowledge dependencies and leads to faster resolution times. And hopefully over the course of this video, you've seen the various hardware, software, and analytics packages available today and how they connect in a SmartWater solution. And that all of this enables you to make better decisions and do more with less. This has been a short glimpse into a SmartWater platform, and we've only just scratched the surface of what's possible. If you'd like to learn more, don't hesitate to reach out through our website or through social channels.